This is Lab 3, and today we're going to measure the acceleration of gravity, and we're going to measure the Earth's mass using a stopwatch and a pendulum. So read through the lab, and it explains that there's some relationships that we can get by combining equations in physics. One is we can get the acceleration due to gravity on the Earth is equal to 4 pi squared times the length of a pendulum over its period. So if we measure the length and the period of a pendulum, we should be able to calculate g, the acceleration due to gravity of the Earth. And then from Newton's law of gravity, that the force on any object should be g times m1, m2. So in this case the mass is the Earth times the mass of the pendulum divided by the radius of the Earth squared. That's how far apart they are from each other. And that's going to equal its weight, or mg. So we can get rid of the mass of the pendulum, doesn't matter, and use that to solve for the mass of the Earth is the acceleration of gravity, the radius of the Earth squared, divided by g. G I've given you here, and the radius of the Earth is 6,371 kilometers. But everything has to be in standard units when we put them in equations, so we need to convert 6,371 kilometers to meters before we put it in. So I want you to construct a pendulum using a string and a weight. The weight is any object that's heavier than the string. It's just going to keep the string tight. You can use a coffee mug, you can use a set of keys, whatever it is you're using, doesn't matter. And string, you just need the weight heavy enough to keep the string straight. And you'll use any measuring device, a tape measure, a meter stick if you have it, whatever. And you just need to make sure that in the end, when we measure the length, we measure it in metric units. If you measure it in feet and inches, you need to convert that over. And you want to go from the center of the pivot point to the center of the bob. And I'll show you this in a video in just a second. The top of the pendulum should be fixed so it doesn't move as you swing your pendulum. In other words, don't use like a chandelier that's also going to move. Your support has to be solid. Then we're going to record 25 complete swings back and forth. And we're going to repeat it 5 times. We're going to get an average period that way, and we're going to use it in our calculations. Of course, in the end, we're going to scan it into a PDF and submit it on Angel. So I have a pendulum here. And it doesn't matter how long the pendulum is, however long or short you want to make it. The first thing we need to do is measure its length. And its length goes all the way up here, where it starts from its pivot point, wherever it's pivoting, down to the middle of whatever mass you're using. And so in this case on mine, it's 188 centimeters. Or you can use whatever measuring device you have. If you have it in inches, like this one would be 74 inches. Alright, so we're going to record that on our data sheet. And once we do that, we're going to record the time it takes for 25 swings. So we'll move it back. We'll start our timer here, and we'll go 1, 2. So each one is forward and back. So all the way this way and all the way back is one swing. And then once we get how long it takes to go back and forth 25 times, we'll record that. We'll stop and we'll start it again, and we'll get 5 or 6 trials so that we know an average time it takes to swing 25 times. So again, as I showed in the example for my pendulum, I recorded 74 inches. Or in my case, I had 188 centimeters. We need to convert that to meters. So for me, it is 1.88 meters. Please don't just copy my values. I want you to make your own pendulum and record your own values. So after I had the length of the pendulum, I let it swing 25 times. First time I got 68.7 seconds. And the second time I got it, I measured 69.2 seconds. There can be some error depending on how fast you start and stop your stopwatch. It really doesn't matter. In the end, we're going to average out all the errors, and that should help. So for me, it was 68.3 seconds, and then I got 68.4 seconds, and then I measured 69.0 seconds. Alright, I wanted to find the average of these, so I added those up. I get 343.6 divided by 5 to get an average of 68.7. Now, the calculator tells me 68.72, but I only really need to keep 3 significant figures, so I won't ignore that. So 68.7 seconds. And that was the time, the average time for 25 swings. So I want to know the time for one swing. So I'm going to divide that by 25, and I end up the period of my pendulum for one swing, in my case, is 2.75 seconds. So we can use this average to calculate the acceleration due to gravity. So from our equation before, we had that g was equal to 4 times pi squared, so that's going to be 3.14 squared, times the length of the pendulum, which is 1.88 meters, divided by the period of the pendulum squared, so that's 2.75 squared. And I calculate that out, I get 9.82 meters per second squared. So that's the value of gravity that I measured from my pendulum. Now, we can use this value of g to calculate the mass of the Earth. We know that the mass of the Earth was big G times the radius of the Earth squared divided by, this is little g, the acceleration due to gravity, radius of the Earth squared over big G. So I'm running out of room here, I'll write over here. So the mass is going to be what we got for g, so that's 9.82 meters per second squared, times the radius of the Earth squared. We said that's 6,371 kilometers, so that's going to be 6.371 times 10 to the 6th meters. Then I'm going to square that. Divide by big G, which is 6.674 times 10 to the minus 11. I calculate that out, and for my value of the mass of the Earth is 5.97 times 10 to the 24 kilograms. So now we've gone through all the calculations. I want you to read through the questions, do your best to answer those, scan your lab, and turn it in on Angel.